Hi guys, welcome to my 4.1.7 Bitwise operators class. It is part of the operators in C++. So I just want to explain you what is this Bitwise operators and when we using that in our programs. For example, if you have like some operations about encryption system like password and this kind of stuff, or even crypto system, blockchain or the other things like trading systems, you can manipulate the bits uh, on another one, or even you can make some uh, compressions and a lot of stuff there. Okay, let's get started. So let's read it in C++. Bitwise operators are operators that perform operations on the individual bits of a variable. There are six bitwise operators in C++. Yes, exactly. We have AND bitwise operators, and this one is like not like our conditional one or even the other one. So the bitwise OR is like that. It is just a long one, and we have the other one here, HOR, which means like it is like OR, but just something different in it. I will show you. We have not like that, and we have left shift and right shift. So, okay, let's get started. Let's say we have two variables, x and y, or a and b. I'm not sure, but let's say x and y, and we will work on the x side, okay? So let's say integer x is, in this case, 5. 5 means we will look in here about bits, okay? What it means, like integer x equals 5. The 5 in computer will look like that. I will show you right now. So let's say we have 4 and we need 1, right? How we can do that? We can say 1, 0, 0, 1. It means this is 4, which is you can check in binary system. The computer starts with the 0 and 1, but in this case, if we're counting it from 0, so it will be 1, and another case will be the power of 2 will be what? 2, and it is 0. In this case, nothing there. And this one is what? 2 and 4, and the other one. But as you can see, it will be 9. But if you do it like that, in this case, and if you put 0 there, as you see here, now we have 1, the other one will be 2, but there is nothing, and this one is 4, and this one is 8. All right, so as we know, this is 5, right? And if you put in binary system with the 8 bit, it will be 1, 2, 3, 4, 5, 6, 7, 8. Like, let's put one more. Okay, so it will be 5. Okay, let's come down. I'm just explaining you to understand all these things. Okay, integer y is equals, let's say, in this case, maybe we can say 3, right? Maybe 3 is the best one. So let's come back down and see what it means, like 3 into the system, like bit system. We can say like 0, 0, 0, 0, 0, and we need something more. So 1, 1. So this one is representing the first one in binary system or in bits. And the second one is the power of 2, which is it will be 2 in this case, and it means it is 3. And the other guys is 4, 8, 16, 32, 64, 128, and blah blah blah. But in this case, we are just looking for the 3, and in binary system or in bit system, if we're counting it, it will be 3. This one is 5, like 101 and 11, like that. Let's get started. Now we will apply something on them. with the and or not and left shift and right shift. So let's get started with the and, for example. How we can apply that? We can just say x equals x. We need to put here 1 minute. Yes. And operator, bitwise operator, and we can just say y. That's all. Okay. So when you run that, let me just make it like that. Okay, let's separate it to seems good. And say handle, and we can close that. What will be output? Let me tell you how we are counting them. So and is, as you remember in conditionals, and is saying like something both side has to be true, right? In this case, we can just compare 5 and 3 like x and y because we're working on x and y, right? Let's come here. So the first one is 1 for the x in the binary system or in bit system. And for y, also first one is 1, which is they are equals to each other, which is both sides true. In this case, we have, let's say, 1, right? Let's continue. By the way, we can just put it like 1, but we will continue. So the other one is x is 0 in this case because in binary system power of 2 it's 2, but in this case it is 0, but this one is 1. And if we like put there or, it will be 1, but in this case the both side is not true in conditions, right? One of them 0, the other one is 1, so it is not true, and in this case it will be 0, right? Let's continue with the other one. So we have here 1 and in here 0. And the both sides are not true. For that, it will be 0. So it means it will give us some output. Let's put there some more zeros. So like x and bitwise and operators onto the y means like 1. So let's run it. If you see same solution, like we need to, because we need to check it, right? Let's run it and see if it is true. 1. Did you see that? It is just gives us 1 as we count here with you together. We calculated, like we check both sides and we see 1 and it is 0 and this one is 0 and the result is exactly 1 for x, right? That's the solution, as you see also here. So it is for and. Let's apply same things for the or. Let's say x is, by the way, let's close this one now and come here. Say x is equals x, put or now, and or bitwise operator and put their semicolon. So now let's come back to the here. As you can see, I will come little closer in this case. We have 1 in here for x and for y it is 1. So both sides are true and it will be 1 in this case, right? Let's come here to calculate for the or. Maybe we can also say this is for and, or we can put that one here. Where is it? Yes. Now let's do same things for the or. The both sides are true, and for that it will be 1. If both sides have to be like false, in this case it is that it is directly 0. But if the one case is true, one condition is true, or even the other condition is true, it will be true. And even both sides, if have been true, then it will be true. Okay. So let's look for the another one. It is 0 for x and it is 1. And it is true, right? Because one condition is our requirement in this case. And we can say 1 again. Or even let's put here 1 to didn't confuse. Let's come here. As you can see, we have 1 and in here we have 0. It is again true because one condition is true in this case and it will be our requirement. So we can put again 1. Let's now put your zeros to complement that. So, and we can say for that it is our OR bitwise operator result. We can say result. We can say result. Okay. Now we can count it. The first one is 1, the second one is 2, it is now 3, and the other one is 4. Now we have 4, 2, and 1, which means 7, right? So we can, by the way, say this 1, it is 7. So let's run and see the result. 7, as you see. Guys, we just doing this stuff and you need to understand what we are doing in here, right? Cool, amazing. Let's continue. So now let's continue with the what with the whore. This one is amazing. So if both sides true in conditions, it is 0. The other case, if both sides are 0, it is what? 1 or 0. Let's think about that. Or even if one side is true about conditions, it will be 1, right? Or not? Let's think about that. So I will come back here like 1, or the other side true, it's again 1, maybe. So let's check together, okay? I don't want to like explain a lot about that because I just want to give you some hints like how we can use it. Okay, now let's look for the whole operator. So how it works. Let's close that one. We're already done with this. We can come down. So we can say, sorry, x equals x, and we can put our or bitwise operator, and this one is the good one for explaining that. We can put this one like up arrow. It is whole bitwise operator. I mean for this one. Okay, then we can put our y there. All right. So now let's look at that. So now we have for x exactly 1, for y, sorry, by the way, let's come here. I'm in wrong place. So for x it is 1 and for y it is 1. So it means if both side is true, it will be 0, right? If both side it's if both side true, it is 0. So in this case we can add our 0, right? Because the both side is 1. It means, like, let's say if x is greater than y, let's say x is 5 and like y is 3 in this case, so it is true. And if we say like if y is less than x, it is again true. So both, if both sides are true, it will be 0, it will be false. Okay, this is another logic gates, don't forget that. But you will not use most of the time that one if you're not working in deep engineering. But so mostly you will use or, not, and ends. I mean, yeah. It is 0. Let's continue with the other one. So we have 0 and we have 1. So it means we have 1 because it is core operator. If one side is true, it will be 1. All right? Let's come here and put there 1. Come to the another one. So in this case, x is 1, y is 0. It will be again 1, right? One side has to be true. If both sides true, it will be false. Just you need to know that. All right? Okay. So if you run that, let's put the remainder zeros to complement with the 8 bits. We can say which one this one is. Let me check right here. Result is, what result is like 4, 2, it is 6, right? Run that and see if it is 6. But I'm just I'm not making joke, but let's see what will happen. Maybe I'm tricking you. Six. No, everything okay. So guys, just know about it. Like if both side true, it will be zero. If one side or the other side true, it is true. I mean, it means one. Okay, just you need to know that. Or operator is like if both side true, the or operator will work for that. But for or, which is with x or, this is just max like if both side true, it makes it false. You need to know about it. Okay, let's close that. Let's continue with another one, as you learned about it too, like how to count it, right? Okay, the other one will be not. Okay, not is so easy, as you know. If it is one, it will be zero. If it is zero, it will be one. I mean, if it is on, let's click on it and press on it, make it false. Or even if it is false, let's press on it, it will be like true in this case. Okay, let's come here and apply same things for that too. Let's say x equals x and put there this one, if I'm all right. Let's check it if it is. No, that's one. So for not, it is not like that. Not my exclamation mark. You need to put there this one. This one, if it is true, let's check it again. Right, that one. So we can just say why. So guys, now look at that. We can count it like what, Let's come here and say for x we have 1, for 1 we have 1. So both side true. What will happen in this case? In this case it will be 0, right? Do you think it is 0? Let's think about that because we have two variables. I mean, you're just comparing them. So if it is 1, 1, it will be 0, right? Okay. But what about the another one? If it is 0, 1, what will happen? 0 will be 1, 1 will be 0. Or we just applying for x? What do you think? Let's say this is 1, now this is 0. So it means what? 0, isn't it? Okay, let's look for the another one. It will be 0. In this case, it will be 1. What's changed in here? If we apply same things for not, like for that and for the other one, it will be 0, 0, right? Do you think it is 0, 0, 0, 0, something like that, or 0, 0, 0, 0, 1? What do you think? 0 or 1? It makes it not. Let's didn't put anything here. Put it there and just say this one. Say result. Let's think about that. Yeah, let's think about that. When you run that, what will happen? All right, what it's saying. Let's run it again. All right, nothing work here, isn't it? It's saying you need to put there this one. Yeah, we did. Nothing wrong there. Before taking this one, okay, we did that one. What happened here? Nothing. Why this nuts didn't work there? Do you think we need to put there this one? Yeah, like instead of the other? Still same, right? Nothing changed. Before this, what it means. So why it makes it like that? What do you think about it? Let's think about it a little bit. How we can apply not exactly there. How we can do that. It is so important if you're interested with the like not, I mean, okay? So guys, I can say we can apply this operator only when you want to complement with the ones, all right? So don't use that one to make it like that, okay? Let's delete that. You can't apply that operator for not. It is just complement with the ones. You can say complement with ones. So if you have, let's say, if you have some codes like 000 and 1 and 0, even like that, it will just, let's say we need like 8 bits. In this case, it will make it like it is 5. We need like 3 bits. It will make it 111. It is complement. Okay? I will show you about it soon. Let's wait there for that one. Okay? So that one, sorry. It is for the complement. Okay? Not. So let's continue. Let's say wait for that. Hey, by the way, not for that, sorry. Wait for the other one. Where is it? Put another quotes there. Okay. Yes. No. Okay. Now we can make a comment and add here. Wait for that. Okay. Now let's continue with another one. Another one is left shift. So left shift is just shifting it with the zeros. Okay, we just putting there some number like how many times we want to shift, then we can just shift. We can say x equals x, then 2 times adding this less operator, and we just saying y, or 2. Let's say 2 for y. What do you think about that? So it is crazy point before we apply these things. What will happen in this case? So guys, we have something more in here. Y. We have also y. How we can apply that? If we do only for x, it's okay, but we have x and y in this case. What will happen if we want to do some operation with the left shift? How it will work there? You need to think about that. So if you have a variable, it will work. But if you have both variables, like 2 variables, it will not work there. Do you think it works? I don't think so. Do you think? So it is most important part, like to understand the concept in here, okay? So for example, let me just come here. I mean, where is it? Just come back to the here. By the way, it is not here. Let's come back to the here. Yeah. So in this case, you can see I didn't find another one, but yeah. In this case, if we put the y like next to that, it will shift it like left 3 times. So what it means, it will shift x 3 times to the left side. I mean, so let me just show you that how I can prove you that I can do it like what, like that. Let's say we have here 1 and we have here 3. Don't look at that, just look at here. So we have 101, like 5 in here, right? It will just add there 20 for the right side, okay? Because it makes it x is 2 times left side. So then just delete these 2 zeros and it will look like something like that, isn't it? So what it means, the numbers change in here. So let's say it is 0, it is 2, it is 4. In this case, we have 4, it is 8, it is 16, 16 plus, let's say, what? 4, it will be something 20. Let's check if it works. I mean, if it is true, our approach. So let's say it will be 0, 0, 0. And if we change the like two side, if we put there, I mean, let's come here and say 1, then say 0, then say 1 again. Okay, we can add our zeros to complement it. So now you can see that the result will be different in this case, right? Let's say result is equals 20 or what? Let's see together if it works. Because we just make it 3 times. By the way, I did 2 times, right? Oh my god, sorry. Sorry, just I forget that to do it. So for x, if we if we tag it three times, let's do it again. If we do it like one, two, three times zero, which is we will shift left. Now we have 101 there. We can add 101 like that, and we can complement it with the zeros. Okay, like that. Put it here also zero. By the way, there's no complementing part. Okay, now what will happen if we do it like that? The numbers will change. So as you see, we have 101 and 000. The numbers are changed. So what will happen the numbers? Let's first run it and see the result. 40. Why it says 40? If we left shift three times there, so you can just count it. It is 0, it is 2, it is 8, so 4, it is 8. We have here 8, right? And we have 16 and we have 32. 32 plus 8 is 40 in bit system. By the way, you need to know how to count bits. This is power of 0, like power of 0, power of 2, power of 4, like this one, power of 4. This one is power of, by the way, let me show you with that one. This is power of 8, let's say in this case. This is power of 16. This is power of 32 or power of, like, it's just going like that, okay? So you can just count it like that. Okay. By the way, 2 power of some numbers, 2 power of 0, 2 power of 2, 2 power of 4, 2 power of 8, 2 power of 6, and 2 power of 32, 2 power of 64, 2 power of, okay, 128, and blah, 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 okay? And it is 255, like in this case. Okay, it is just equals 40 because we just left it three times to the left, and our 101 for the x is 101 there in here, and we added there 3 times 0, which is we like shifted left with the y, that one, and the result after counting x is just 40. Okay, so let's continue with the right shift. Let's close that. I think we understand the result or our work. Let's come down and say x equals x and put here y. Now guys, what's changed in here? Just think about that. What's changed? Now x is 5, y is still 3. So we will shift y 3 times right side now. So in this case, we just left it, like we added our numbers to the this side to shifted our like x values, x bits to the left side. Now in this case, we will put from here to right side. So what it means, now we have 101 again. Let's do these examples together. So we can say, let's add the 3 times 0 to the this side now. And what we have there, x is 101 from the right side. So let's complement that. Like we have 3, 3, 3. In this case, if it's go the right side, 3, 3, 3, like that, we need to delete like 3 times these numbers. And it will be what? 0. Do you think it is like that? If yes, let's try that. Okay, like 101 will be absorbent in here. Will be nothing there. Okay? Will be 000 because we shifted right side 3 times with the zeros. Why not 1? Because it is zeros. We just sang zeros. Okay, let's run it and see if it is like that. Yes, 0. As you see, we just shifted 3 times to the right side and it just come here, and 101 in this case just be ghost, being ghost, right? It is just 0. Okay, result is result not the result is 0.